Hello guys, welcome you all for this end-to-end session of data science where we're gonna learn everything that you guys need in order to become a successful data scientist from a scratch, guys. From working with data, how to use machine learning concept, deep learning concept. We're gonna see the NLP, and then we're gonna finally end up with uh, generative AI, and we're gonna see lots of project, guys. Okay, so hope you guys are enjoying. We are enjoying a lot, and we are learning. We are just improving our knowledge each and every day. Hope the same thing for you guys. If you stuck anywhere, if you guys have any doubt, just ping us and leave the comment section. So leave your doubts in the comments, so we will take up and we will solve your doubt. We are here to help you. Okay, so hope you guys are enjoying. So guys, as always, before coming to the session, make sure you guys watch all the previous session videos so that you can have a better understanding of what we are talking. Okay, so yeah guys, so today it's going to be a continuation session of DBSCAN. Previous session we have introduced you what is DBSCAN, what are the key concepts in DBSCAN, those things we have seen. So today's session it is a continuation of DBSCAN that we have done for the previous session. So without wasting any time, let us jump into today's session. Today's session is all about advantages of DBSCAN. Let us start with it. Okay, so advantages of DBSCAN: cluster shape flexibility. It can identify clusters of any shape, making it suitable for complex data distribution. Yeah, so I think we are discussing each and every slide of DBSCAN about this. DBSCAN is not fixed to a certain shape, like it should be a spherical or it should be something like tree. No, it can be any shape. So that's it is very flexible. Then outlier identification method. So it's one of the very I will say it's a finest method to find the outlier or in a data set. DBSCAN effectively identifies outliers which can improve the accuracy of other machine learning algorithms. Yeah, once you remove the outliers by using this DBSCAN from the dataset becomes pure. So now you can apply any kind of algorithm to do your detection kind of thing like classification, regression, or dimensional detection, anything that you need. Okay, forecasting, anything. Okay, this DBSCAN acts as a layer where you can remove the outliers. Okay, hope you guys can understand. Next, minimal parameter tuning. Yeah, DBSCAN requires fewer parameters compared to other clustering algorithms, make it easier to use. Okay, we have discussed, right? Just you need to tune the epsilon parameter as well as minimum value. Epsilon is the radius, whereas the minimum sample that we are having, right, in minimum points, that is in order to make a core point, how many points should be around it. So like that, only two parameters, minimum point, and then we are having something called as epsilon. We need to fix those parameters in order to make this DBSCAN works best. Okay, so these are the advantages, guys. Hope you guys can able to understand. So yeah, sir, over to you.
Yeah, advantages of DBSCAN, guys. First is cluster shape flexibility. It can identify clusters of any shape, making it suitable for complex data distribution. Then we have second, outlier identification. It will identify effectively outliers which can improve the accuracy of other machine learning algorithms. Minimal parameter tuning. Okay, so you know what is parameter. Parameter is the attribution of data. Okay, the characteristics or the what are the like characteristics of the data, that tuning. Okay, it helps minimizing parameter tuning. DBSCAN requires fewer parameters compared to other clustering algorithms, which makes it easier to use. So these are the three elements of advantages of DBSCAN. Let's move to the other section.
Yeah, sure, sir. Yeah, what are the limitations of DBSCAN, guys? As we are mentioning, right, it's a two sides of coin. Whenever we're gonna have a advantages, then there are gonna be some disadvantages of the algorithm. Okay, every algorithm has its own pros and cons. Okay, so let us see what are the limitations of DBSCAN. First is density variation. DBSCAN can struggle with the clusters that have varying density, especially when the density difference is significant. Okay, since it is density based clustering technique, whenever the density changes, right, it starts to hallucinate. So that is one of the disadvantages of this model. High dimension, yeah, DBSCAN performance may degrade in high dimensional dataset as the distance calculation becomes more complex. Yeah, if we are having single dimension, we can go for something like a single or two dimension. We can go for a Euclidean distance, and we can use line formula for a single dimension, like those things. But like when you are going for a high dimension, right, the formula for calculating the distance becomes more complex. Okay, that's the reason this DBSCAN applying application in high dimension becomes more complex. Okay, it's like I will say directly proportional. Whenever it becomes complex for us to go for the distance formula for the high dimension, then this applying this DBSCAN to the high dimensional data set, it becomes tough. Okay, then parameter sensitivity, yeah, while few parameters are required, DBSCAN can be sensitive to the choice of values of epsilon and mean point. It's both advantage and disadvantage. Guys, can you able to understand? In the advantage, we have said that it has only two parameters. Just need to take these two parameters. But since it has two parameters, so it has two parameters, that is an advantage. Since it had two parameter, a mild change in any one parameter can lead to a completely different model, completely different error. Okay, that's the reason you guys need to properly fine tune these two parameters. Okay, so yeah, these are the limitations: density variations, high dimensions, dimensionality, and then parameter sensitivity. Okay, hope you guys can able to understand. Yeah, sir, over to you.
So we have limitations of DBSCAN, which is disadvantages guide. So density variations. DBSCAN can struggle with the clusters having varying densities, especially when the density difference is significant. So density variation is a limitation. Then high dimensionality. So DBSCAN performs performance may degrade in high dimensional data set. So high dimension means when there are a lot of dimensions in data, we also do dimensionality reduction, right? So can you write what is that dimension? What algorithm we use for dimensionality reduction in the comment section? Okay, as the distance calculation become more complex, like high dimensionality, DBSCAN performance may degrade because of high dimension data set. Okay, as the distance calculation becomes more complex. So this is the another limitation. And then parameter sensitivity, while fewer parameters are required, DBSCAN can be sensitive to the chosen values of epsilon and minimum points. Okay, so these are the limitations of DBSCAN. Understand it properly, deeply, and absorb the information, digest the information, and apply the information long-term objective with patience, persistence, and perseverance continuously, guys. And if you have not subscribed to our channel, subscribe to our channel and press the bell icon so that you will get notification on time. Keep learning deeply with long-term vision. Thanks. Let's move to the other section.
Yeah, sure, sir. So moving on, let's see what are the applications that we have, because like in the previous session we have introduced you the working of it, the back blocks behind this DBSCAN. Today we have discussed the what are the advantages and limitations. Then let's see what are the application, guys. Again, I am mentioning it is not limited to these three things. Since I have space, I have just put these three applications. Wherever you are having the application of machine learning, you can use this DBSCAN. I will say not machine learning. Whenever you have a data, that's a baseline. Whenever you have a data in any industry, then you can use this algorithm. Okay, first application is customer segmentation. Identifies a group of customers with similar purchasing pattern. Hope you guys already understand. Okay, because like we are discussing this application for the, I think, more than 5 to 6 applications for different machine learning models. Okay, so what is this customer segmentation? We're gonna find what is the group of a customer. Okay, whether they're gonna buy, they are having a less salary and spending more, or more salary spending less, or more salary spending more, or less salary spending less, like that. Okay, like that customer segmentation. Fraud detection, yeah, detect unusual transaction that deviates from the normal patterns. Yeah, since it is used to identify the noisy data as well as outlier, this is very important, very easy for us to do for the fraud detection. Image segmentation identify distinct regions in the image based on the pixel density. Yeah, since it's a density based clustering, you guys can see here, right? It's an entire frame. From this entire frame, here the place where I hold, right, here the density of the cluster could be more high, not could be, will be more high, okay, when compared to the other backgrounds, okay. So when it detects the density as high, you can predict there is some object. So using this DBSCAN, you can do it. So this is what called as image segmentation. We are segmenting the background from the original image. That's it. Okay. So yeah, this is some of the applications. I will say very few. I will say 0.001% of application of this DBSCAN. Okay. Hope you guys can able to understand. Yes, sir. Over to you.
DBSCAN applications in data science or AIML, customer segmentation, wherever you need customer segmentation, you can apply DBSCAN, identifying groups of customers in similar purchase patterns. Whosoever has customers and wants to identify groups of customers in similar purchase pattern, they can use DBSCAN. That's it. Fraud detection. Wherever you want to do fraud detection in financial system or anywhere, so detecting unusual transactions that deviate from the normal patterns. It can be in any industry, guys, fraud detection, wherever financial transactions are part of its operation, so you can use it. Again, becomes a wider application, and image segmentation is narrower because it is used wherever you can find the regions, identify distant regions in image-based pixel identification. Okay, it can help in identification, it can help in application and different wherever image segmentation you require. These are the applications of DBSCAN. Let's move to the other section.
Yeah, sir. So yeah, these are the applications, guys. So make sure you guys just explore. There are more applications for this model. Okay. So these are the main application, I will say. So let's move for the next slide. Okay. Yeah. So I think this is gonna be a last thing. Conclusion and future consideration. So first thing, effective clustering technique. Yeah, this is the effective clustering technique because DBSCAN effectively identifies the clusters of varying shapes and size. Since this is not limited to a single shape like a spherical or a tree, this is an effective clustering technique where you are able to cluster the data points in any shape and size that you need. Then future enhancements, research is going on to improve this DBSCAN's performance in handling high dimensional data and density variations. Yeah, these are the two errors. Like those are the disadvantages that we are having. So that is, whenever you are moving for high dimensional data, then the formula for distance calculation becomes more complex. So it is very difficult for you to apply the DBSCAN. So there is some research is going on to fix that issue. Similarly, varying density. So the thing is, whenever you are having density in a varied form, right? Whether it is like split it up manner, you guys are not able to find. Yeah, okay. This is the cluster that I need. Okay, that's the reason. So there is in this place also there is some research is going on. Okay, then real world applicability. So for example, DBSCAN has numerous applications in the fields offering valuable insights for decision making. Okay, we have seen different real world applications, right? Like fraud detection, transaction for failure detection, and then something like customer segmentation, like those things. Okay, so it has many real world applicability. Okay, so yeah, guys, this is all about DBSCANs. Like I will say, these are the conclusions and future ones. Okay, so future consideration that we can do. So yeah, so over to you.
Yeah, so conclusion and future considerations. Effective clustering, DBSCAN effectively identifies clusters of various shapes and sizes. That's it. Effectively identifies clusters. Clusters means groups of various shapes and sizes. That's effective clustering DBSCAN does. Future enhancement research is going on improving DBSCAN's performance and handling high dimensional data density variation, because that is the limitation, guys. That's why research is going on to improve the performance on high dimensionality, okay, handling the high dimensionality data and density variation. Real world application, DBSCAN is numerous, it has numerous applications, various fields offering valuable insights in decision making. This is all about DBSCAN. So now we can know that DB density, what is DBSCAN, okay? So it helps us to identify density in the clusters. It helps us to find the boundaries in the data set, okay, with the similarity of the data in the clusters. Okay, it helps us. It's very powerful. It can find outliers, anomalies, but it also has limitations like the high dimensional reduction, like high dimensional data. It cannot perform well. Okay, and uh, it can identify clusters of various shapes and sizes. And this is all about DBSCAN. Let's conclude this session and move on to other session. Thank you. Thanks a lot. Keep learning deeply with a long-term objective function. Go and watch all the sessions 5 to 10 times. I'll say more than that, because the more the reinforcement learning you do, the more better the performance is, guys. And we build models. We do a lot of iterations to get the best performance. Similarly, we human beings have to learn best lot of time so that we'll perform well, we understand models well, we'll understand concepts, and then we also perform well. So these all concepts come from human beings, and we are now applying to machines and algorithms. Okay, so keep learning, do iterations, lot of iterations for learning. Keep learning deeply with long-term vision, with patience, consistency, persistency, and perseverance. Deeply. Thanks a lot, and subscribe to our channels. Also press the bell icon so that you will get notification on time, and give us feedback each time we want to improve each session, guys. We are there. We are open for improvement. Keep learning. Thanks.
Yeah, guys, sir is mentioning, yeah, so please make sure that you have subscribed to our channel, so and press the bell icon, because like every day we are just uploading a new video, so that you guys doesn't miss any of our video. So this is all about today's session, guys. We have introduced the theoretical concept of DBSCAN, the black box behind the DBSCAN, everything. So in the next session we're going to see the coding part, so don't miss it. That's the reason we are asking you guys to subscribe, so that you can get a, and also just press the bell icon, so that you can guys get the notification of the videos whenever we upload. Okay, so yeah, that's it from my side, guys. If you guys have any doubt, just ping in the comment section. We will take up and we will solve your doubt. We are here to help you. Okay. So as always, guys, take care. We will all meet in the next session. Bye, guys. Take care. We will all meet in the next session. Bye.